Good evening. With show of hands, I want to see how many of you enjoy being paid more than that pizza. So my name is Xiaojing Wang, and I work for ADP. And I don't know how many of you know about ADP. A lot of you. So ADP started as a payroll company. So one thing is, I give you a perspective. U.S. has 150 million people in the workforce. For a given year, ADP pays about 30 million. So we cover a big base. But 10 years ago, ADP expanded the business line. We're not only paying people, we also manage benefit. We manage recruitment, basically the time, the workforce management. We have a suite of HCM software. So here you can see the total number of clients and total number of users who use our product across the world. So I work with here ADP for 4 years. One thing, my background is actually from internet space. I work for CNET in data warehousing and advertising data mart for about 10 years. The last, I was actually doing optimizing ad delivery for CNET, and that's where I pick up the data science stuff. So, you know, if you think about internet company and ADP, you see this is a drastically different type of companies. So what's there in ADP that's special? I want to say that if you imagine, you know, you have a set of data that goes back to more than 10 years. It covers 1/5 of the workforce, and then you include all the most intimate details about people, about company, and then that's the most unique data set, and that's also lies opportunity. Well, when you look at the data set, one thing is that, you know, with internet, easily one day we're handling what, 5 billion log lines easily. That's, you know, not a big deal. But if you look at ADP's data, it, you know, whole year doesn't have that much. But what ADP has is each record is embedded so many details. So I sort of thinking that with internet data, you want to compress it and find journeys in it. With ADP's data, you sort of want to take each of the piece and expand it. So there's a lot of interesting things. Today I'm going to go through, you know, what are unique about ADP's data set, and what about the challenge that we're facing, and show you some machine learning cases, and share our methodology. So, you know, machine learning is a hot area. Everybody's talking about it. One thing I really find this is interesting is that, you know, as a data scientist, one thing is you need to know how to think, and then first teach machine what we do, and then learn from machine how we can do better. I want to, today's talk really is I want to share our journey, how we think about our data, think about our business problem, and how we link those together and produce a data product out of that. Obviously, all the machine learning is, everything starts with data. I talk a little bit about what's special about ADP's data. One thing we're doing is not only we're using ADP's proprietary data, but also we're getting a lot of external data, specifically about people, about their jobs, about company, about the company, which industry this company resides, how the company is doing financially. So the idea is that we really enrich ADP's data points with a lot of external data and make the perspective a lot more complete. And this is probably a first step. You know, everybody doing machine learning too, you have to first get the data. So if I want to show you, like, in terms, there's so many data, you know, from different domain. How you view those? One way to look at it is this 3-dimension really. The most critical part is first everything about employee. Well, for roughly, you know, we have 90,000 clients, tens of small company, but a few thousand really multinational big client. And then with one is employee data, and the second is when you organize the employee into a unit, that's organization. You know, people, when you look at as an organization, there's a lot of attribute about that too. And then third is you want to see as with time, you know, as along the time horizon, how people change and how organizations evolve. So first, let's look at what kind of dig a little bit deeper. What kind of data we have about employee? So start with ADP payroll, and then we have time, we have benefit, we have recruitment, and then further is about the payroll. And there's a very detailed, as you can see, each of those domains we can actually go very deep into it. And then second is we have company-centric data, and what do we do with it? This piece is actually, if one thing I want you to remember tonight, this is something that I think is very unique to ADP, because what we're planning is, you know, this is the first time, because we have such a huge repository of all kinds of companies in different industries, small and big. We can actually benchmark the characteristic of those companies along different dimensions. For example, what is business function? We can actually show company of different size, how are they distribute their resource along product development, sales, and let's say support, in marketing, in different, or legal, all that, in different stage of the involvement of the company. When they're small, you know, where they tend to put their resource, and when their medium size, where they tend to grow, what are the area they put the most resource in growing them. So that's one. And the second organization is we can actually benchmark the structure of company. Is first of all, we can say span of control, meaning what's the average number of direct reports each manager has in which layer of your organization, and typically, you know, how many layers a company has, you know. And right now we're finding out roughly there are 7 is a average number. A lot of company follow that, 7 layers from CEO to the bottom. And then we can also benchmark workforce characteristics, such as, you know, in what type of company they're using more extended workforce, flexible workforce, what type of company, you know, what's their ratio of full-time and temps, what's their age distribution, things like that. So that's the first type we do benchmark. And then the next, what we want to do is identify, you know, the high performing companies. You know, we know as a business, ultimately your test is whether you're successful or not is you make money, right? And for the companies that makes money, we want to see what are the factors that really have a positive impact on their financial numbers, what are not. And we want to pick out those high performers from peer group. So what is a peer group? Usually small companies, you never compare your company with Google per se, but you want to say, you know, how is my company comparing with my peers? The peers, this usually implies that, you know, company in the similar space, in terms of industry or in terms of specific specialized field. Second, the size is similar or the revenue size is similar, right? So why we're doing this, ultimately, the ultimate goal is that we wanted to show company what are the growth trajectory and what are the factors that influence your growth for small size, for all company of all size in all stage of development. So that's what's the third box. And this part of insights, I think, is we feel that it's ADP in a perfect position to produce this kind of insight for our client and create a product to share with people. So this is just a very rough example of attribute we have on companies, on employee, on organization, just so that, you know, you guys get a sense. So it's all, you know, when I talk about ideas, it seems to be all great, but when you actually look at the data, there's a lot of challenge, right? The first one is all the data we have is actually transactional, and you know that with privacy, number one, you can't use PIIs, we can't use CII. You know, I have never worked with a company that you know, as an engineer, we work with lawyers so much, you know. So we get billions of data. Number one thing, we have to mask out all the PII, CII to the extent that satisfy the lawyers, and then we can move it to the cluster. And for all the results we produce, for all the models we produce, first we have to review with lawyers. So that's a very interesting exercise. But that's very, very important because ADP is very super conservative in that we want to make sure that whatever we do, we respect people's privacy and data security is number one thing. And the reason I put it out there is actually, as engineer, we spend and data science, we spend a lot of resources to do that one. And second is, so when I talk about the data point and people say, yeah, great, you know, we have so much valuable data, but we as data scientists, when you start looking at it, you know that all the data are dirty, right? It's not a single piece of data is ever satisfy your needs, and it's always something's missing. You want it, and something is inconsistent. So actually the first area we use the machine learning is to deal with those problems. So here you can see that I just want to give you a sense, level description indicated whether you are individual contributor or you are a manager, or you're, what layer are you at? And we have the 4% of that data is actually not in the data set. And then if we go down to the reporting hierarchy, that's increased to almost 60%, more than majority. We don't have that data. So that we're facing this wide range of problem. We actually create, first things we create models trying to fill in those pieces if we can. And second is consistency. So if you just look at that, you can see that the occupation saying this person is senior housing manager, but the level saying it's a non-manager. And reporting hierarchy saying there's no person report to this, but then indicator saying it's a manager. So the point of this is that when we inspect our data, it's only 44% they are consistent across all the attributes, and majority, more than half, is not. So how do we deal with that? And here I'm giving a summary of in which area we're using machine learning. So first, normalization, what I mean here is that, ADP has wide range of clients. And for a lot of the key attributes, such as the job, the type of job people do, the organization name, whether it's marketing, or each company have different kind of names and different kind of string to describe those. So first thing we do is we need to make sure that the same thing to extract a common, I would say, common data across all the clients so that we can actually benchmark those. For example, we actually normalize job level because you guys all know in financial in banks, right? VP means different things, but if you're in other company, VP is is some level, and so the job level is we actually based on the semantic of the level information. We not only use the titles, but we also use the reporting hierarchy. We use pay, all rich set of data to derive levels from the use models to derive levels, and then we can, this way we normalize the levels across companies, and then we can benchmark on those. Same with bonus type and business function. The beauty with business function is we actually can, that different company, their structure are very different. Some CEO, if you look at all the reporting, the first level, right? Majority you have chief marketing officer reporting to a CEO, and then there's sales, there's a support, there's a product development. But how they organize this, some tends to go very flat, some tends to go deep. Business function is sort of is taking out the structure, but grouping the organization, grouping people by function. A data scientist, you can belong to product development, but you can also you can do data science work for sales and marketing. Then your business function would be very different in those two cases, right? Regardless, you have the same titles. So idea of business function is we are able to capture group people by function, ultimately what their job, the goal is, and then we can see how companies are allocating their resource among those. And then classification, well, the biggest one is job classification. You guys all know that Google recently published that a job API that allow a lot of application can call and to classify. And for ADP, it's a little bit different. Not only we need to take a job description, but also we need to take all sort. The reason being, our description is never like resume, have a full rich sentence. We have a lot of snippet of the words, and then we have which department this person belongs to. We have the industry they're in, and sometimes we have their manager has title. So we actually have around 8 pieces of the information all together, and then feed into our job classification engine to spell out the job category. And we're actually able to match with any standard job category classification. I know you guys know that ONET, which is a standard occupation classification that used across ADP, used across U.S. government agency. We can map to that, and then also right now we're currently working on ADP Lens, which produce a job classification that's a lot more detailed. So that's job. So we're able to really classify people, the type of jobs they do in a very, very deep level. And then we have industry peer group. We go beyond the NAICS code. I know majority of you guys, majority of people go with NAICS, and we are going 2 directions. One is we actually create our own industry hierarchy, and the second is we are able to use the overview of a company and classify them and create a peer group that deeper than NAICS code. So last is validation and forecast. So I talk about we do a lot of benchmark, and we also create scores for organization and for employee. But if you think about it, it's very hard to validate. Why? Because BLS produce a lot of benchmark, but BLS data first is surveyed, and second is it stays at fairly high level. For us, we're intended to produce benchmark at very deep level and in all sort of categories. So how can we validate that's the right one? And it's actually pretty deep. So currently we are, the way the approach we're taking, we're actually using multiple algorithms and create variations of validation approach, and then we use data to observe using the trend, trying to pick out the validation approach that's most sensitive, meaning that when the underlying data change, it can change, and then it capture the essence of what we're looking for, and then compare across. So those are. So if you really think of what we're doing, you know, the way I would like to say is that we are actually, in the beginning, we're teaching machine to learn from human data, right? All those data, the missing data, inconsistency, just because of human make mistake when we enter that. And then as machine gets better, then the next is that the human is going to learn from machine. And that's where we are doing. The next one is we want to do HCM intelligence engine. What it does is that, you know, all the insight I was talking about in the beginning, then we want to integrate them together and then bring all those into the HCM workflow. And when people use our ADP's application, they don't have to go through training or anything. Whatever they do, and then we will have hint, teach them along the way, and use, you know, for example, use a chatbot to. What I mean by lean old and new world is, you know, people right now still get used to use applications, you know, log in something and click on some links and what to click and what to show, you know, that's we can actually embed our intelligence in that, you know, to recommend the metrics they should look at, and based on their actions to say, you know, if you want to achieve this target, those are the metrics you should look at. So idea is sort of like you have a intelligent agent help you along using our application, and we can even promote best practice. Why I say automatically is that, you know, if we see your company is at a certain stage, and then you're trying you're measuring some key metrics, we can always to say, you know, other companies similar to you at this stage, those are the key things you should look at, things like that. In general, the approach we're taking when we do machine learning, we don't sample ever. We all look at the whole set. And the majority of the package we use is open source. We use, obviously, Python is a lot of it. But H2O, we start using H2O because it's just it helps us to move from research to production a lot faster. And then we cross-validate a lot. When I say cross-validate, I don't mean the traditional machine learning. I mean, we're not sure which model works the best or right or wrong, because there's a lot of times we use 3 and 4 different algorithm, different model, and then across validate the result that way. That helps us a lot in terms of understanding our data, understanding algorithm. And interestingly, we still manually label a lot, manually generates the labels, but we're trying to reduce that further in the future. So I talk about validation. What I find, I don't know you guys, is that's the case, is actually it's really hard to validate models. You know, when you guys learn the machine learning, the method is always, oh, you have a training set, you have test set, and then whatever the measure you got from test set that tells you the model is great or not. And that I never believe in those, because, right, you know, when you actually deploy your model to the real thing, you find that's really the case, right? You get this great model, you have all the scores, this and that, and when it's really as good as that. So a lot of times the way we validate is we validate as I said before, is across using different algorithms. That's number one. And number two is we use business logic. You know, one set of data, in order to perform certain, achieve certain level, it has to have some hidden business logic reflected in some different areas. So you got to use this to validate. I give you example, for example, the job level I talk about. You know, once we predict out what's the job level, how we validate that. You know, one thing you know that if you predict the level, then when we benchmark the salaries per level, it has to have some sort of steps, right? You can't have a, you know, benchmark for lower level have a higher benchmarked salary than the, you know, the higher level. So we actually, that's approach we use is we benchmark and then we compare whether that's rule being broken or not. So I believe in validation. Really, you can validate. You have to validate use a real business case, business test. So I'm going to touch base a little bit on how we use deep learning. Deep learning is another buzzword. Everybody wants to talk, saying they're using it. For us, we actually find it's really, really useful. Why? Because we have a lot of categorical data, and a lot of times, you know, the string, all that is different, but the semantic is same. And the key with the job, with industry, all that, you want to know semantically they mean the same thing. Doesn't matter, you know, how the form is different, right? So and ADP, we have one thing is good. We have we have a lot of those data. So it really fits the model of a deep learning. We actually use heavily in all the categorical related models, such as those I listed here. And we also use it to do unsupervised and use those anomaly detections, trying to figure out, because we have so many data, and sometimes, you know, we see anomaly that's due to either error or it's just some case that's really seen. So it becomes anomalies, such as, you know, we pay, some people get millions, you know, pay in a quarter. Why? Maybe they're actor, actress or something, but it's quite interesting. So this is nothing new. I'm sure you guys know that. But what I want to point out is that the reason I put model as the last one and then with the core is the model activity compared with all the engineering analysis actually is highly concentrated, but the period is pretty short relative to other two. The analysis take a lot longer, and engineering takes a lot longer. Engineering not only in scale, in automation, but also in being able to enable analysis large scale. So here is our tool set, the course tool set. I'm sure most of you are familiar with that. There's nothing interesting. We use Spark a lot. And we use, currently we use deep learning, majority we use H2O. We are experimenting with TensorFlow. And I know, you know, and also working with H2O closely, trying to see what are the things that they want to enable first. So here is just to give you a sense that the data product produced, based on all the things we did, is we have a compensation explorer, and essentially you can find, any job in any area, how much should be the pay is, and what's the bonus, overtime, things like that. And here is another product, turnover probability, is we're able to predicting the likelihood of a person is leaving the organization. Yeah, so I'm hoping that, after a while, after the machine is so good, then our data scientists can work on something that make fun things funner than engineering stuff. That's it. Any questions? Okay.
Question about the turnover probability.
Yeah.
What dimensions of information do you consider?
That's a great question. So ADP, we have two kinds, right? We have the company they work for, how long they've been there, and the type of job they do, the area where they are, and their commuting distance, their how long they worked in which position for how long, their performance, what sort of bonus they get, what sort of promotion they have been getting, that sort of thing. So we do realize there's some other aspect, right? There are engagement, survey-based, but we sort of trying to use the performance data as a proxy of that. Yeah.
How do you determine which jobs are going to be obsolete over, let's say, 5 years, 10 years, 15 years because of automation, especially with AI stuff?
You mean personally? I think about, or you mean from data?
Yeah, from the data, right? Like Uber right now, right?
Yeah.
Where they're experimenting, for other companies, car companies, where self-driving, right?
Yeah.
It's gonna change the dynamics of the workforce.
Yeah. So I can say two aspects. Right? One is we're actually planning to do analysis, because we have more than 10 years of data, right? We want to see over this 10 years, how the job landscape changed. And we can actually see, in the beginning, we actually already see some evolvement of the job, how it's changed. Used to be there's a certain job title, like COBOL programmer, it's very, very atop of the job, and then now it's like small. So that's from data we can see that. But from other side, you can see, I know people talk about anything that can, there's a lot of things can be automated. For heck, data scientists can be automated too, part of that. But I think it's probably going to take a while, especially if you're the top tier of what you do. I still think it's hard to replace. First, you got to teach machine to do a better job, right? Yes.
And do you break down ages, like sex, these kind of?
Yes, we do. We do. When we do model, we do, and usually when we talk with the lawyer, they always cut a lot of it. No, you can't use that. Yes, but we do analysis of that. Yes.
Do you provide any aggregate information about the employers and how they design their organizational hierarchy?
Yes, we do actually, and that's one thing I think we can actually do really well is we want to produce some sort of data product like help small companies to really have something to rely on to help them grow. Because you know, actually ADP, I don't know, you guys know WFN is our big part, is one of the most the part with biggest population. A majority of the company are actually less than 1,000 people, right? So we have a huge population of small companies, and we want to help those companies grow, and because we do see what kind of company be able to break into the past to grow. And you know, as you guys know, majority stay flat or go down, but there are a few population they do. We want to identify what did they do based on the data, and then help the others to do a good job. So that's the area we actually want to put a lot of emphasis on. Yes.
Can you talk a little bit about automation of analysis?
Yeah. So I can tell you, like, the one thing is automatically, you know, everything, when people give you a piece of data, first thing you do, what distribution, right? You want to see what sort of distribution it has. And what we did is we actually have a set of script that we created. So our idea is that, you know, if we know we're going to do something more than 3 times, then we want to think a little bit we certainly prioritize to make it a tool. So we have a tool set that allow you to just point the source of your data, and then it will generate the distribution, generate the missing the ratio of missing data, all sorts of things, and automatically. It's not automatic when you have to call the tools, but it will generate the report for you. And also, currently we're working on the model that we can identify what we consider as the outlier based on this attribute, you know, things like that. Yes?
I appreciate it's a big challenge to normalize the data, and we need things to be consistent.
Yeah.
Do you use any government sources like Department of Labor to help normalize job titles and things like that?
We started with that. We started with, in fact, in the beginning, I don't know, you heard the autocoder, ONET. We actually would rely on that. But then we realized it's just not enough. So that's why we break to do our own job. We're actually working with a startup to do our job classification. Yeah.
In terms of the millennials, right, where they have a different model working,
Yeah.
right? Like mobile, like more open concepts, like
Yes.
Google type of environment.
Yes.
So you mentioned that you're working a lot with the SMC market. Because, you know, as more people are retiring and being replaced, and also just to grow, how to attract the millennial workforce? You guys make suggestions to that? And how to keep them?
I'm not sure you're talking about keep track per se, but I know that for us, we actually we put a lot in the mobile space. For all the tools, we already have a huge mobile application space. And if I give you an example, we actually just create executive suite on the mobile. And the next is we want to include more insight directly in the mobile as you use it. It suggests you what to do, simplify your flow. Specific to Millennium, we can certainly, I don't think we did, but we can certainly do analysis on cut out the Millennium population to see their pattern of job switching, their pattern of promotion, that sort of thing. Yes?
I don't think I saw geography as one of your data challenges before.
Yes.
Is it predominantly domestic information that you're using here, or how do you approach kind of international?
Yes, that's a great question. Actually, geographically, it's actually a big, most important dimensions. I didn't include it just because I just want to illustrate point. In fact, we started with zip code, right? And then we can map zip code MSA to all the different spatial hierarchy, and also we can go down to census block. But currently, all things we do is domestic, is U.S. based only. International, the privacy law is issued. Where the data is hosted that we can access to another issue. So we are U.S. based, and then immediately we're going to include North America data, and then international. We have a plan for international. It's just it's going to be a little bit slow. Yes.
How do you decide the window of data to use? I mean, do you downgrade all the data, or like it's 5-year data, or whatever data you have? Like some industry might change over the course of the year. The data might not be the same.
We actually, this is a part we don't decide. We include everything. What I mean by that is that compared with internet data, the people data, company data is rather relatively small. However, we got to, once you attach all the surrounding information, I give you example, NAICS code, right? The industry is just one code, but this industry code, you can expand to many more information about that, right? You can roll up to different hierarchy, and you can also go down to the sub industry. So what we do is we keep all the source data, and then if there's any metadata shifting, we just reattach a different metadata to it. Like, you know, NAICS evolves too. So we're able to say when we want to use the newest, the 2017 NAICS, we just attach that and supply and replace all the older code on one shot. So we have a source repository, and then we have a very powerful engine that being able to take out this piece of data and plug in whatever view we want to get out of that. Yes.
Could you mention about the size of organizations, from very small to very large?
Yes.
Are you running into issues with unbalanced data while modeling?
Oh, all the time, right? Imbalanced data is just like, for example, turnover probability, right? When we look at the train the model, you can see because majority of people, they don't leave, right? The turnover rate in general is less than 30%. You know, but average is 10%. So that is a view, is a, you know, what we, it's a normal case. And we just, sometimes we, when I say oversample, I'm not meaning sample, but when we train the model, you balance it. Okay.
At the macro level, do you map it to the GDP globally? Based on GDP, you can expect certain amount of job growth.
No, we don't. No. So I would say that if you view the macro, I would just consider organization level is where we go with, because our goal is not to produce any research type of stats. Our goal is we want to produce data product for companies to use. And then there's a lot of, in other scenario, there's a lot of consulting company, they want to get our data, you know, that sort of thing. But in general, we don't go to macro. We have a research institute group. They do produce some higher level stats like national employment report, all that, for I would say economics sort of purpose. Yeah, but my group is more on the product side. Okay.
I saw something called on the core data definition. Suppose that one of the slides we was talking about the data definitions, like the core system, CORE.
Which one? In the beginning?
Yeah, it was part of it.
Before this point? Sorry.
Yeah, the core data definitions in the top.
Ah.
Is it like any tools or technologies for the data stewards to maintain the definition?
That's a great question, because my boss asks me all the time. You know, I said, yeah, I don't know. There's a tool. No. So we actually look at elation. We look at, I think we look at the Cloudera have a thing, Navigator, and it's not there. Yeah, I actually periodically we look at those. I don't think anything is in place. So currently we're actually, my boss is saying we're going to probably build ourselves a little bit. Yeah. Okay, great, thanks.